Hey guys, welcome back to the channel. I have another Marine ECM. This time it's a MEFI 4 for Walter Soldani. This is a 5.0 Volvo Penta GXi-E. He sent this computer to me. Walter is from Florida. Yes, so we are in lead with his information. Let me just look for his email. I always create a report that I have all the information pulled out. I don't want to direct the camera because it has his email, so I'm just going to read. He said he found me through YouTube. He's from Kissimmee, Florida, and he would like to take a look at the ECM 2006 Volvo Penta 5.0 GXi-E. I just can't find the problem, and he thinks his ECM is bad. Um, he's an army mechanic, but it's a little bit over his knowledge or testing ideas of what he already has done in the boat. So he said the motor will crank, but no star. He put in there, but now star. I think it's no star. He has replaced distributor cap and rotor, coil, spark plug wire, spark plugs, fuel filter and pump assembly, ACI sensor on the throttle body, cam position sensor. He has cleaned the injectors, flipped the manifold, and I'm getting ready to spray. I have got really good spark from the coil. I am not getting good spark from the wire, even though everything is new. So that is a little weird that he has good spark on the coil, but not a spark on the distributor cap. So I will check that in there. All right, so let me remove that, and I'm going to open his history. I always save a file for him. This is before I even work on the computer. I just connect it and read the faults, and we have 34 manifold pressure sensor voltage low, 41 EST signal has an open circuit, 81 cam signal fault, and then 41 EST fault, ESTA fault. All right, so in this one, based on his um, serial. I think I closed it. So let me go over to Diacom. With Diacom, I have not reset the fault. So as we can see, we have still full four fault codes right here. So trouble codes four. Even though the computer is running, I have both bankers of injectors, 2.5 milliseconds. We can see they're blinking in there, and the fuel pump is on. So everything is working good. The computer has been running, and I've been testing it for, let me just see, time, 32.87 minutes. It's been running in idle, no problems. I have 700 and, let me see the RPM, 748. We can get some of those up. Again, the manifold or pressure is reading good. I can have it in here, and then the voltage, I'm going to change that. So, oh, another thing that I forgot to mention, this is the 5-volt reference. It's in sensor ground, so they are good in the computer. I have the EST signal because this is a EST computer. That's a um, module for the ignition. He might have replaced the distributor, but not that, and I will recommend him to do that. Check all the connectors. And this is just a substituted value for the coil, right? We got the IEC opening and closing and good. So I'm going to change the values on the map so we can see that I can go up, and that's going to change the injector millisecond. Right now we're 4.6. Obviously that is too much but an idle, so I'm going to go down to 12.5, which is usually where I keep it. But we can see that the voltage goes up and down as I change it. So the computer is reading that properly, the scanner is reading that properly, and I know the computer is changing because we can see the difference on the injection from 4 point something to now 2.5, and it's clean injector signals. So that is not a problem. The EST is working good. I can change the RPM, and we can see how now that test light is getting brighter and brighter. The less RPMs I put, the less it's going to be showing, that light in there. Let me just get a little closer. So I'm going higher RPMs. We can see, at least I can see it with my eyes, how it's getting brighter and brighter. Um, right now in 1100 RPMs, and the boat is working good. So what I want to do is, now that I have this here, is go over the codes. And this is the nice thing about Diacom. If I click on here, this is going to ask me to select a boat manufacturer. This is a Volvo Penta, and this is going to open in here and tell me, what are you working on? So this is a MEFI 3, 4, and 4B. So this is a 5.0 GXi. So I just click in here, and this opens this workshop manual, which is built into Diacom. I'm just going to click Control F, which is going to let me search, and let's put, code 81. Let's say so. I just put 81. Let me just minimize this ones. Not sure if I will be able to use it later. Yes, I can. I'm just going to minimize, and then again we can do the search. This is going to, anything that shows us 81 is going to be shown in here. And I have gone into all this in here, so I got in his folder all that information because I'm going to send that to him. So we got again those 3 fault codes. I'm just showing you how you can do it if you have Diacom because all that information is there. So code DTC34, manifold pressure circuit voltage low. This is definitely not in the computer. So I'm gathering all this information for him to check again the 5-volt reference. As we can see here, DTC34 is intermittent, locate and repair open or short or to ground and 5-volt reference, and it tells you where that is located. I have also gathered that information for myself. Oops, sorry, I gotta cover this. And I have, let me just go out of here because I have that information. I always have this. This is like a generic picture of the J1 and J2 connector for me, what I mark all the main signals, and then we can see where, the 5-volt reference is, where the TPS, the air temperature sensor, the CKP, and all that is located, injector, IAC, and all that. So yeah, so this is very, very good. We can see the J22 is indeed 5.0 reference right here. So sensor ground J23. So I will definitely send all this to him for his information and for his testing. This is again just a manual. This is a complete workshop manual for Volvo Penta. So if you have Diacom, you can do that. You can check all the folder codes. And this is what I'm going to send Walter because again, the computer in here has been running with no issues for all that time. So I'm going to reset the faults. If this happens here, we will see it exactly. So we have a problem with the cam sensor signal. So what we're going to do is let's see, cam sensor present on, and this is I'm a little tired with my hand holding the phone. Sorry, a lot of work. But yes, now we are down into one fault. Cam sensor signal on this computer is produced. It all depends on the design. So I need to talk to him and see if he has a TVI or a multi-port fuel injection system. And then if it's a cam sensor that is a multi-port, the sensor will be on the front, on a cover, and then he has to check that one up. I'm going to also change that signal because I can change that with my simulator. Let me just, before I do this, let me stop the computer. So we're going, because you can see here, cam and crank. So what I'm going actually, before I do that, I'm going to stop the video 1 second, put the oscilloscope on the signals and see what we see there so you can understand what I'm providing. And then because this looks like it's not blinking, it's because it's just a 50% on and 50% off. It's just a 1x on the cam sensor signal. So let me stop the video. I'll be right back. All right, I connected the oscilloscope so we can see the signals. I'm going to have everything like this. It's a lot better. So we had as I put the signals in here, we got the blue channel will be the CKP, red channel injector, one of the injectors. Green channel is the EST, and yellow will be the CMP, camshaft position sensor. So we can see again, let me stop that capture. So we can see that the cam is on and off, 50% on, 50% off. EST signal is produced and is working good. This signal is produced by the computer, not by me. So this is a signal that is being sent and then is I consider, I mean, it's working good. So I'm very familiar with this, and I know this is really good. I can also see if I make a zoom on this injector that the injector actually is looking really good. Let me, okay, it did actually zoom. So we can see that it's a nice and clean signal coming from battery voltage, and it's pulling down to pretty much 2 millivolts. So that injector signal, sorry if I'm a little too far, is good. So battery voltage, so 12.2 sorry, 2 volts, 2 not 2 volts, sorry, 2 millivolts. So that is perfect. Nothing wrong with that. So all signals are there, all signals are present. So what I'm going to do is I'm going to turn the computer off. Let me reset default because sometimes the faults will not reset even though all signals are there unless you do a key cycle. All right, as you can see, everything is perfect. Injector, both injectors on, cam is on. It looks like that fault came back immediately. So let's go over to codes, and we do have the cam signal fault. So either it's not liking the signal I'm providing, or we have a problem with that signal. Although, and again from experience and location of these cam sensor signals, this computer will run even though the cam sensor is not there. And this will not prevent the computer from running. It will use just the crank sensor signal, and then it will run. But okay, the computer is here to be repaired. So what I want to do is I want to open the computer, make sure that we don't have a broken wire, because I know that that signal, which I am the one supplying the signal, is there. So now what I want to do is remove the computer cover and then analyze inside, make sure that we don't have a broken jumper or something that is getting not letting the signal get into the computer. But for the rest, again, this computer should not have a problem running. And not, he said, is a crank no start. We can definitely see that even with that fall, we have injector milliseconds and we are getting coil activation. So again, this is not the problem that he has, that the computer is, so that both is not running. Um, I will definitely give him some recommendations to check the harness. I can definitely see the computer is a little crusty. Hopefully you guys catch that in. So we definitely might have water intrusion in the engine room. So I would recommend him to check his harness, check the firewall reference, check the sensor grounds, and otherwise replace the harness. Sometimes a little hard to find. I have found one seller in eBay that has some of the harnesses that may not be specifically for GXi-E, but the differences are, allocation of one sensor here, or it uses instead of the MAPS air, manifold air pressure sensor, and then a separate IAT or intake air temperature sensor. It uses a MAT, which is a manifold air pressure sensor with the intake temperature sensor built into one sensor. That is most of the time the differences. And with a brand new wiring, at least you can, if you need to add a wire or reroute a wire, it's very simple and it's start to chop out and try to make a brand new harness. All right. So that's what I recommend to my customers and my friends. All right. So let me open this computer, see what I found. For the rest, before I do that, let me raise the RPMs to go. We're going to go over to 4,000 RPMs. So I'm going to raise the RPMs there. Let me get the throttle position to around 30%, 40%. Let's do 40%. And let's change the map a little bit. Although, right now at that idle, we can see the difference on the signals. They're all there. They're all working good. We can see it also on the simulator that is reading the both injector banks really, really nice and clean. Not problems at all. So this is the second run, and we are getting 3.5 minutes, and we only have that full code. So all the rest of the codes are gone. So they're most likely to tell me that the problem is in the boat and not here. Still, again, want to address that fault. So let me open this up. I'll be right back. All right, guys, I am now with the computer open. I don't see anything wrong in here. I'm now wondering if I have a problem with my connections, maybe a wire broken on my harness, or indeed something is not really reaching inside the computer because, so what I did is I have still on yellow channel the cam sensor signal. I'm using the blue channel, which is the CKP, and then to check if what I'm supplying here, if I touch right here, so we can see that now the signal, the blue and the yellow are a match. So the signal is being sent out, but it is reaching the computer, yes or not. So connector J2, which is next to this side, we will have pin 16 is the CKP and pin 32 is the CMP. So I'm going to touch, I need to get my glasses off because this is, I gotta be careful what I'm doing in here, right? So I'm going to touch right at the jumper on the back on the CKP, and we can see that indeed the signal for the CKP is there. So again, that's pin J216. And now I'm going to touch J232, which should be the signal for the CMP, but I'm not getting it. So why I'm not getting it, I'm not sure yet. So I'm going to, because I'm definitely there. I am definitely on there. I can, hopefully you guys are seeing what I'm doing. I'm going to touch carefully in the front. And again, I am not getting no response. If I do the same thing, touching the jumper coming from the CKP, we can indeed immediately see that there. So I'm going to get the trigger off just to make sure that I'm not being fooled by a trigger that might be having a high level. And then for some reason, let's say, because it should be both around the same amplitude, but let's get no trigger. So we're not going to be fooled by a trigger that is the signal not reaching the same amplitude again. So let me just do the test again on the CKP. So we immediately see that the signal is produced. I'm going to move that to the CMP signal, and we got the same result, so nothing. So let me check my connection, make sure I don't have a pin out or something that is producing the signal, I mean the code, and there is nothing wrong with the computer, it's actually my connection. So let me just double check that, and I'll be right back. Well, just flipping it around, look what I found. So we found our missing signal, and definitely I'm going to fix this and uh, retest. So if this is the case, then it's nothing wrong absolutely with the computer, and all the problems are in the boat. But yeah, let me fix that out. I'm going to again open the connector, and then I mean there's no other signal missing, so I'm pretty sure that that is indeed the signal, which actually we can do that right now. Let me run the computer. So we got that same thing in here. I'm going to use the blue channel here. And yes, that is our signal. We can now see that that is indeed the signal that I'm using. So, yep. All right, guys. So let me fix this up. We're connect everything back together properly and then retest. All right, guys. I replaced the terminal. Yeah, it was just, pull out. This is a little, because sometimes I do most of the times this is I have to flip the computer and that put a stress on the connectors and that's it. But yeah, so right now, as you can see, we got 0 volts. The computer is running at 709 RPMs. I'm going to do the same test that we did before. So let me get my glasses off and I'm going to show you that now, obviously, indeed, we have the signal going properly. So I'm going to now go straight to terminal 32, J232, and we can see now the blue and the yellow are green. So now the signal is reaching the computer as was supposed to be. So yeah, so again, this is all the tests that I want to do. I was able to run this computer, and again, well, that cam sensor should not stop the vehicle from running. It will probably give a long cranking and long cranking until the computer uses just the CKP to start and put a signal strategy to keep you going. It will definitely set up a fall. It will be long cranking, long cranking, long cranking because it's try to find its position of piston one. But with the CKP that this computer uses, it can do that. Same thing, a vehicle will do the same strategy. It's timing. So yes, it's definitely important. But as you can see, this is a on and off signal. So this is not a high definition sensor. The CKP is a high definition sensor. There's more teeth on it, so the computer can use just that. Again, it will try to fire on one and looking at the results of load, and so it will change the strategy to the other one. It's only two positions, right? It's either on or off or backwards at the same time. So that's what I would do and put the strategy to run. But yeah, again, it's nothing wrong with this computer. Right now, we got absolutely zero faults. We can see that now. Remember, this was immediately generated. And at first, I thought I was having, maybe the wrong signal supply. And I even went over to the wiring diagrams. I have everything for Volvo Penta, and I was looking at the wire diagrams to see where the cam sensor is located and if it was indeed going to the pin 32, because depends on the application, it might change, but no, this is exactly what we have. So CKP, I'm sorry, CMP is 24, and we can see that it goes into J2. Again, look at the bracket right here. I'm trying to point in here. This is pin 32, and then cam sensor right here. So yes, I was checking everything. So I am indeed perfectly testing the computer. All is normal here. Nothing wrong with the computer. Injectors are clean signals. The computer is running good in high RPMs and in low RPMs. So I'm going to increase again. I saved this already for him, but I'm going to go over to 4,000 RPMs. That was just a clip in the holding the computer in there. That's not a problem. So let me just go around 4,000 RPM. We can see, the stretching of the signals due to RPM going higher. But yeah, we are actually 4,300 RPMs. I'm raising the throttle position values just to see the results of injection changing, and it does. Everything is good, clean signals, no problems at all. Coil activation, we can see is definitely getting there. So all signals are there and no fault codes. So right now we got a start without malfunctions. One right there above the throttle position and the throttle codes. So I can definitely bring the RPM down again. 700. Get that throttle to a normal reading, around 5-7% on idle. That's what I give here. And then we can shut this off. I'm going to completely power off, so we lose communication. Power on again to see the fuel pump prime and all this there, and then start again. So yeah, this is going to refresh. If we disconnect the scanner and connect back, let's just still, oh yeah, now I updated. You see to start without malfunctions as 2. So yep. Again, Walter, this is your computer fully tested. I'm just going to put this so he can see that these are indeed the numbers on his computer, and all is good. All right, so I'll be sending this your way, give you some recommendations and tests and so orders that you can do on the boat. But yeah, all the computer is good 100%. All right, guys, I hope that you like this content, and you see this is exactly what you need to do. I mean, you're missing a signal and it's creating a fault code. This is also checking in right now that the computer logic is 100% good. Um, Oscilloscope is just one of the best tools you can have for this. You can try to get a handheld oscilloscope like the U scope. It's very inexpensive and it's very handy. I mean, I will probably not get it myself because of my vision. I need to wear glasses and I want to see something bigger. But then, I mean, you can get a picoscope online and eBay for cheap connected to a laptop, and you're going to have a great tool to do all these same tests that I did. I mean, you're missing a handshake position sensor. If you just replace the sensor, but you don't check the harness, you're going blind. You can just replace parts, but it's going to be hard. So, Walter, I can recommend you to try to get maybe an oscilloscope. This is pretty easy. All you need to do is make sure that you are using all the ground. Again, this is a 4-channel oscilloscope, so you can see four signals at the same time. When you're checking different signals, as I am doing in here, you want to make sure that all the grounds for the leads, because these leads will have the color is going to be your signal, and the black is a ground. So always connect the grounds to the battery ground. Like that, you know, if you have a voltage drop. What is a voltage drop? Let's say, you know, you're checking the signals with the sensor grounds at the computer, and you might read okay because this is a differential test. Remember, the computer, or not the computer, the oscilloscope will show you the differential voltage in between the 2 points that you're using if you measure using the battery voltage. And now you read, let's say, you know, you're checking an injector or even the cam sensor signal, and you're reading 0 to 5 volt because you're using the sensor ground. That's the difference on those 2 points you're measuring. If you use the battery ground and now you measure only 1 volt, that is the reality of the case. So you either have a dirty ground, you have a problem on the signal, then you can see those things with an oscilloscope. But yes, I always recommend to use all your grounds to the battery ground. And then you can check different signals as I use here. Right now, I have the signal. Let's say we can say here, this is the signal on the general channel right at the sensor, and this is the sensor signal right at the computer. We know that that signal is reaching the computer. Before it wasn't, right? So this is a broken wire. Exactly, this is a perfect situation to show how important it is to test the harness and how important it is to have an oscilloscope. You can check with a multimeter if one wire strand, two wire strands of that wire is still touching that terminal, the multimeter will tell you we're good because it's not loaded. So again, it's a lot of tests that I can share and show you that will make you very good technician and also help you repair your boat, in this case for Walter. And I'm trying to save as much as information. As you saw, I put everything on his folder, and I'm going to send all that information to him so he can try to narrow it down and get his boat back and running and enjoying. All right, guys. Thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.